right, children. So this video is basically to explain how to solve one variable equations. Again, I'm making this video as support because more of you are having trouble with this than I anticipated, and I need to quit doing that. I need to quit assuming that we're just gonna, have it down. Um, so that said, so let's say I had, I don't know, 2x plus 3 equals, let's see, 15. Okay, so this one's simple enough. I don't think anyone has any trouble with this kind of equation, right? But all we're doing, right, there's two ways to think about it. You're doing PEMDAS in reverse, right? In reverse. So instead of starting with grouping, right, when you're solving equations, you're going to always start with the addition subtraction, okay? The other way to think about it, if you have a kinetic brain, meaning to you, things kind of move around in your head, or you can visualize better when you think of things moving or like in terms of space. If you've got that kind of uh, way of thinking, right, that's how my brain works as well, right? I'm thinking I'm working from the outside in to isolate X, okay? So I don't know. Everyone's different. Um, Either way, we're going to start at the same place, especially on this equation. Okay, so for example, we would start here, starting here, right? This plus 3 is furthest away from the x. Or, right, addition subtraction is what we're going to get rid of first. So I'm going to do minus 3. What I do to one side, I do the other. 2x equals 12. Then what's happening? So this is the part that also mixes up a lot of you, right? So if I've got two numbers scrunched together like this, namely the 2 and the x, that means they're being multiplied. What is the inverse of times 2, right? Dividing by 2. And therefore, x is 6. Okay, so let's look at another one. Let's see if I can come up with a more difficult one that works out nicely, which I doubt. So let's say I had, I don't know, 2x over 3 minus 5 equals 6. Okay, so yeah, that's not going to work out nicely, but whatever. We can still just show the steps. So again, still utilizing order of operations in reverse, or I'm working from the outside in to the x. Okay, so either way, I begin by undoing the minus 5 by doing plus 5 to both sides. Okay, so I've got 2x over 3 equals 11. Okay, now to me, in my brain, I think we get rid of the 3 first, right? But you could also get rid of the 2 first. It doesn't really matter. I'll show you both ways just to illustrate that. But simplest thing to do would be the inverse of dividing by 3, right, is to multiply by 3. And what you do to one side, you always, that's a golden rule of algebra, what you do to one side, you always, 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 always do to the other. Okay? Then we see we're going to just divide by 2 at the end, right? So our answer would be 33 over 2, or if you like decimals, which I don't, but if you like decimals, you could say 16.5. Okay, so now let's get a little bit more gnarly. Okay, now this has really been throwing you guys off. Okay, so let's say I had 2a minus 5 equals a plus 3. Okay, so here, and you can see I keep using the same numbers. That's weird. Anyway, here, nothing really changes, but what's throwing you off is that we've got the variable on either side of the equation, right? So normally we've got something a plus B equals C, and we're trying to get A by itself, and blah, blah, blah. The variable is only on one side, right? But that's not the case here, right? But we can definitely make it look that way, right? So we can definitely just say, well, I want to take this A, do its inverse, right? So this is a positive A, yes. Its inverse would be minus A, and what I do to one side to the other, I'm going to combine it with its like term on the other side of the equation, namely the 2A. Those combine to give me 1A minus 5 equals, this is gone now. And now it's a little baby simple equation, and we know that A is going to be 8. Okay? Let's get even crazier. Let's get real crazy. Let's say I had 7A, there's a different number, minus 4 over 2, all of this over 2, is equal to 1 half minus A again. Okay, so now we've got some ugliness. Not only do we have A on either side, right, our variable on either side of the equation, but we also have these satanic fractions here, right? Well, as I've alluded to in a lot of other videos, if you've got a denominator that you don't want, just do its inverse. What's the inverse of dividing by 2? To multiply by 2. So that takes care of it on this side. This is the part where you guys get messed up. What you do to one side, right, you have to also do here to the other side. But you have to do it to everything on the other side. So that means el distributo. Okay? So 2 times 1 half, that's what happens here first, right? 2 times 1 half, well, that's just 2 over 1 times 1 over 2, which gives us 2 over 2, right? Because you multiply straight across, which is just 1. Or you could just realize, well, duh, I've got 2 over 1 times 1 over 2. These 2's cancel and leave me with just the numerator of 1, right? Either way, you just get 1. So 1 minus, well, then, 2 times A, that's 2A. Then it just becomes what it was, in the last example, right? So I want this A to go over here and combine with this A. The only way to do that is to do its inverse, which is plus 2A. But I do one side, I do the other. I have to combine it with its like term on the other side. So that would be 9A minus 4 equals 1. Then I add 4 to both sides. 9A equals 5. Then I divide by 9. A is therefore equal to 5 over 9. Okay, so let's do one more ugly example like this. Just one more. Just one more. Similar to one on the AP, what was it? AP1 that gave y'all a crap ton of trouble. So let's say I had 1/3. Let's say I had 4/3 minus 3x is equal to, we'll say 4x plus 8. Okay, no idea how this is going to work out. It's probably going to give me an ugly fraction again, but that's not the point. Okay, once again, we've got a fraction here. Don't want it, right? How do I get rid of this denominator so that it's just a 4 and I don't have fractions anymore? Well, duh, I do the inverse of dividing by 3, right? So I'm going to multiply by 3. But I have to multiply everything by that 3. Otherwise, this is not algebraically sound and the equation becomes unbalanced. Okay? So 3 times 4 over 3, well, that's going to cancel that 3 out. That leaves us with just 4. 3 times negative 3x, that's minus 9x, equals 12x plus 24. Okay? Now, I'm just going to get my x's on one side, right? And I don't know about you, but I like having the variable on the left. It doesn't really matter. In this case, I'm just going to put it on the right so that it's positive just so I can show you. So I want to move this 9x, this minus 9x over here with its with its buddy over here, the 12x. And to do that, I have to do its inverse, right? What I do to one side, I do the other. I have to only combine it with its like term on the other side. So now I'm left with 4 equals 21x plus 24. Subtract 24 from both sides. I get negative 20 equals 21x. Divide by 21 on both sides. Negative 20 over 21 equals x. Okay, so hopefully that video is helpful to any of you that have been having trouble with solving little equations like this. Otherwise, I'm here all the time for tutoring. Goodbye.